When food enters the stomach, a complex series of processes begins to break it down, allowing the body to extract nutrients and energy. The stomach plays a critical role in the digestion process, receiving food from the esophagus and preparing it for further digestion and absorption in the small intestine. Upon arrival in the stomach, food is mixed with gastric juices, which contain hydrochloric acid, enzymes, and mucus, all of which work together to digest the food. The stomach is designed to handle these acidic conditions, and its lining is protected by a layer of mucus that prevents the acid from damaging the stomach walls. The first stage of digestion begins when food enters the stomach. The stomach's muscles contract, creating a churning motion that mixes food with digestive fluids. These muscles also help to move the food down toward the lower portion of the stomach, where further digestion occurs. The gastric acid, mainly hydrochloric acid, is highly corrosive and plays an essential role in breaking down proteins and killing harmful bacteria that may have been ingested with food. This acid also activates pepsinogen, an enzyme that transforms into pepsin, which begins breaking down proteins into smaller peptide chains. The enzyme pepsin is especially effective at breaking down the bonds in proteins, turning large molecules into smaller ones. While this process begins in the stomach, it is not completed there. The stomach's acid environment is also necessary for dissolving minerals, such as calcium and iron, making them easier to absorb later in the digestive process. Once food has been mixed with gastric juices, it turns into a semi-liquid substance known as chyme. The stomach's muscles continue to churn the chyme, ensuring that it is evenly mixed with digestive enzymes and acid. The chyme is then gradually released into the small intestine, where the majority of digestion and nutrient absorption occurs. The pyloric sphincter, a valve located between the stomach and the small intestine, regulates the release of chyme into the small intestine. It opens periodically, allowing small amounts of chyme to pass through. This controlled release ensures that the small intestine does not become overwhelmed and allows the enzymes and bile in the small intestine to work more effectively on the chyme. Once in the small intestine, the chyme mixes with bile and pancreatic juices. Bile, which is produced by the liver and stored in the gallbladder, contains bile acids that help emulsify fats, breaking them down into smaller droplets. This makes it easier for lipases, enzymes secreted by the pancreas, to digest fats further. Pancreatic juices also contain enzymes like amylase, which begins breaking down carbohydrates, and lipase, which continues the process of fat digestion. In addition to enzymes, the pancreas also secretes bicarbonate ions to neutralize the stomach acid present in the chyme. This makes it easier for lipases, enzymes secreted by the pancreas, to digest fats further. Pancreatic juices also contain enzymes like amylase, which begins breaking down carbohydrates, and lipase, which continues the process of fat digestion. In addition to enzymes, the pancreas also secretes bicarbonate ions to neutralize the stomach acid present in the chyme. The acidity of the chyme would otherwise damage the walls of the small intestine, but the bicarbonate neutralizes the acid, creating a more alkaline environment ideal for the enzymes to work effectively. The small intestine consists of three sections: the duodenum, jejunum, and ileum. The duodenum is the first part of the small intestine, where the majority of chemical digestion occurs. Here, the chyme is mixed with bile and pancreatic enzymes to break down proteins, fats, and carbohydrates. The jejunum, the middle section, is primarily involved in absorbing nutrients from the digested food. The lining of the jejunum is covered in villi, tiny hair-like structures that increase the surface area for absorption. These villi are covered in even smaller structures called microvilli, which further amplify the absorptive capacity. Nutrients such as amino acids from proteins, fatty acids and glycerol from fats, and simple sugars from carbohydrates are absorbed into the bloodstream through the walls of the small intestine. The absorbed nutrients are transported to various parts of the body via the circulatory system, where they are used for energy, growth, and repair. The ileum, the final section of the small intestine, continues to absorb any remaining nutrients that were not absorbed earlier. Additionally, the ileum is where vitamin B12 and bile salts are reabsorbed to be recycled. Once the digested food has passed through the small intestine, it enters the large intestine, or colon.